This video will show how to create the following two small Octave programs. First, creating a new Octave file in an empty directory, implementing it with a trivial program, printing the classical phrase "Hello World" to the screen. Then the Hello World program will be replaced with another program, which receives input argument from the command line and also receives keyboard input from the user. This video is part of at least one playlist showing how to do the above with different programming languages. There should be a link to that playlist in the description below. Prerequisites. You, the viewer of this video, are assumed to have some skills in at least some programming language. I will not explain basic concepts such as what is a variable or what is an array or what is a for loop. Even if you have never written source code with Octave or MATLAB, you are assumed to be able to understand, for example, what this Octave code below does. Octave and MATLAB is similar enough that a substantial amount of code written for MATLAB can also run in Octave without needing to be changed. In this video, I am using Windows 10. I start by showing which version of Octave I have installed. The version of Octave is 6.4, but in the end of the video, which I have recorded at a later time, I am using Octave 7.1. The Windows command dir shows that the current directory is empty. In other words, that I am starting from an empty directory f:\dev. There I create a new directory called Octave with the Windows command md. Then I navigate into that directory with cd octave. Then I start Visual Studio Code by typing code and a dot, which is the path to the current directory. When Visual Studio Code has started, I create a new script file named arguments_inputs.m in the new directory. I am implementing the initial trivial Hello World script by calling the function disp to print Hello World on the screen. Then you can execute the script by typing Octave and then the name of the script file. When the script is executed, then Hello World is displayed on the screen just as expected. The function disp can be used to easily display the contents of a variable. An alternative to the function disp is to use the functions printf or fprintf, which are more flexible and can be used to format the output. The formatting with printf and fprintf is similar to the function printf in the programming language C. The function fprintf can receive a so-called file descriptor as an argument, but if it is omitted, then you are writing to stdout, which is usually the screen, and then it corresponds to calling the function printf. \n is the line break character. One possible reason for preferring fprintf over printf is that the former is obviously documented also for MATLAB, which is an advantage if you write code for Octave, which you also want to be able to execute with MATLAB with as few changes as possible. However, I would like to point out that MATLAB is commercial software that I do not have access or license to use, and therefore I have not been able to test if printf is also available with MATLAB programming. In any case, it does not seem to be currently listed on this MATLAB webpage with functions. When I search for printf, I can only find fprintf and sprintf. On the other hand, when reading the Octave documentation about printf, compatibility with MATLAB is mentioned, so I think it's a bit ambiguous. But in my opinion, it is more obvious that the function fprintf can be used by both Octave and MATLAB. So therefore I use it instead of using printf. When the script is executed again, this time with fprintf, Then Hello World is displayed on the screen again, in the same way as when the function disp was used. Now I will replace the initial trivial Hello World implementation with a program that will receive and print arguments from the command line. The program will also ask the user to enter a name and will then print to the screen what the user typed. For this purpose, I have prepared some pseudocode that I will paste into the program, but within commas, since of course it would not be possible to execute. Then I will modify the code by changing it to Octave code that can be executed. Now I am showing how the program arguments will be provided for the program when it is executed. The arguments will be added after Octave and the file name, and then a space between each argument. So here I am showing 3 arguments for the program. I will iterate the program arguments in a for loop. The indexing of the elements starts at 1 and not 0, as in many other programming languages. The upper limit for index iteration is obtained with the function length with the arguments, which I will soon create. Any program arguments are available from a function named argv, which returns a cell array that I receive into a variable that I give the name arguments. I can also mention that the function argv seems to be specific for Octave. In other words, it does not seem to be available when you are instead using MATLAB. Inside the for loop, the iterated program argument is printed to the screen by calling the function fprintf. \n is used to create a line break. Curly braces are used to retrieve the string at the index I in the cell array arguments. When the script is now executed with 3 program arguments, it works as it should. Now I will show another way to call the script, namely as a function with the same name of the file and the function. Now I put the code inside a function with the same name as the file, except for the file extension .m. That function receives an argument that I give the name arguments, which is the same variable name that I previously used for the return value from the function argv. Then you can call the function in the file by using the Octave flag --eval, and then the function call in quotation marks. Here I am now using square brackets to create a matrix as an argument. Here you could use a cell array with curly braces instead of square brackets. And in that case, I would not need to change the code inside the loop, where an element is referenced with arguments and an I in curly braces. But here I am showing an alternative to using a cell array, namely a matrix. When you create a matrix, you use a semicolon to separate the rows. I am using single quotes for the strings in the matrix, and double quotes surrounding the entire function call after the flag --eval. I replace the function length with rows, because when using the function length for a matrix, it is equal to the largest of either rows or columns, and therefore length would not always work. But in this example, it would happen to work because in this matrix I use 3 rows with 3 columns. In other words, 3 characters in each row. Since I will now use a matrix instead of cell array as an argument, I also change the code inside of the loop in such a way that I replace the curly braces with regular parentheses. Then I use the loop index I for the row and the colon for the columns, because I want all the columns to be included in the screen output. In other words, all the characters in the string. When the function is called, it works like the previous script, which was not the function, and then was called by simply entering the file name instead of the flag --eval and the function call within quotation marks. I can also mention that I ended the for loop by typing end. But if you look at the documentation for Octave, you see that N4 is usually used instead. Both end and N4 can be used with Octave. But one advantage of using end instead of end4 is that MATLAB uses end, and by using end it will be easier to make the Octave script to be compatible with MATLAB. Now I will implement the second part of the program to receive input from the keyboard while the program is being executed. I am using the function input that receives an argument that should be the text you want to display before the input prompt. The returned string is stored in the variable name. By the way, the function input seems to be also available when you are using MATLAB. The content of the variable name is then printed to the screen with the function fprintf and the string hello as prefix. The second argument for the input function, s, is used to specify that the value returned should be a string. \n is used to create a line break after printing hello and the name. When I then execute the function within quotation marks and with the flag --eval, it works as it should. Now I will show how to execute the code from within the Octave's command console. I start the command console by typing Octave. So far in this video I have used Octave 6.4, but this last part of the video have actually been recorded at a later time. And as you can see, I am now using Octave 7.1. I will call the function by first copying what I had written inside quotation marks after the flag --eval when I previously executed the function from the Windows command prompt. When I then paste the function call to the command console and execute it, it works as expected. Now I have used a matrix as an argument with square brackets around the strings. And now I will switch back to using a cell array again. In other words, the same data type returned by the function rv that I used earlier in this video. Therefore, I changed from square brackets to curly brackets, and from semicolon to instead using comma as the separator between the strings. When I then execute, it does not work. I also have to change the code a bit to handle a cell array instead of a matrix. Instead of calling the function rows, I call the function length, which returns the number of elements in the cell array. I also changed the indexing, which with the current code assumes that arguments is a matrix and therefore uses regular parentheses and then I, comma, colon, which means the line I and all columns, in other words, all characters, which is specified by the colon. Now, when arguments should be a cell array instead of a matrix, I use curly braces instead, and then an I for the element number I in the cell array. When I then try to execute again, it works as expected. Now I will try to call the code in the file as a script from within the command console by using the function source. The argument to the function source is the name of the file. It fails with the error message that arguments is undefined. Arguments is the name of the variable that is the argument to the function. As I am now trying to execute the code as a script, I delete the declaration of the function. In other words, the code is now instead outside of any function. Since the program arguments is used, I now return to creating arguments in the same way as I did previously in this video by calling the function argv. When I then try to execute again, it works without any error. But on the other hand, no program arguments are iterated, of course, since no program arguments have been provided. Then how can you provide program arguments when executing a script in this way with the function source? I have not found any obviously good way to do it. But one possibility is that in the command console's session, before the call of the script with the function source, you can redefine the function argv so that it returns the program arguments that you want to provide for the script. Here I define the function argv so that it returns 3 program arguments. When I then use the function source to call the script that calls argv, you can see that it worked. The program arguments are iterated and printed to the screen. Now I will end the Octave session and then restart it, just to show that the function argv has not been permanently destroyed with these hard-coded values returned in my redefinition of the function argv. Now, when I have restarted the Octave command console and called the function again, you can see that argv has been restored, since it no longer returns the program arguments that I had hard-coded in the previous session. But now I redefine the function argv again with hard-coded strings that are returned from argv, and then execute again, and then it works again as expected.